138. The slope of the tangent line at a given value of velocity versus time gives what? So now I just kind of answered this. I have a graph of velocity over time. Let's say it does something like this. Now the tangent line intersects the curve at one point. Okay? What is that tangent line representing, though, when you think about it? What it is this is actually the instantaneous rate of change, delta V over delta T at the point T. Okay? And so what is it's really the slope at that point, right? If I were to zoom in really close, the slope of my tangent line would be very close to the slope of the curve. In fact, if I were to zoom in at only the point, they would be the same thing, right? So this is, what's delta V over delta T? Acceleration. And it's not an average acceleration, it's the instantaneous acceleration. Does that make sense? We'll learn a lot about that in calculus. The reason Sir Isaac Newton invented calculus was to calculate instantaneous velocities and instantaneous accelerations. Okay? So you need calculus to graph that. 139, it says the slope of two lines connecting 2 points on a velocity versus time graph. Now this is an interesting one. I'm going to delete this here. I'll just start over from scratch, I guess. Same scenario, boom. And this is my velocity. Oops, I wrote that down wrong. Velocity and time. Now I could pick 2 points on the curve, like this one, and this one, and draw a line between the two. But what is this giving me?
Slope.
A slope between 2 points. Is that the instantaneous acceleration or what?
That's the instantaneous velocity.
No, this is like t sub 1 comma v sub 1, and this is like t sub 2, yeah, v sub 2. And so to find the slope of this thing, which is my acceleration, I've got delta v over delta t, but it's not at a point. Now, it's probably parallel at some point in time in between these two, but see, the slope here, which represents the acceleration, is different than the slope here. So what does this line right here represent?
Average velocity.
Well, not velocity, but
Acceleration.
acceleration. So that's the average acceleration. Does that make sense?
Yeah.
Okay. Good. Next, problem 140. So now we got to be careful because they say all the graphs look the same, right? Like position over time, velocity over time. So this time they want position versus time. So now I got my position, or sometimes your textbook will call that a S or an X. We'll put X over T. And it says the slope of the tangent line. So now this represents my position over time. And the tangent line is going to touch exactly one spot. Now this right here is X over T at a point. What is the change in position over the change in time? Because to find the slope of that, at some point, would have to have delta x over delta t. So the slope of the tangent line represents what? Think about what I'm saying. It's the change in position over the change in time. Velocity. Is it instantaneous or average?
It's instantaneous. It's just
Yep. So it's the instantaneous velocity. All right. Guess what the next one is? All right. So now this one. Same scenario, except now we're going to do 2 points. Now, the slope of this green line at any particular point we said was the instantaneous velocity, but my velocity is different here than my velocity here. What does this blue line, the slope of this blue line represent? An average. Thank you. You whispered it. That's correct. It's the average what?
velocity.
Velocity. Does that make sense?